Hello everyone, this is Vishal Dake, Assistant Professor, Electrical Department, Sardar Patel, College of Engineering, Mumbai. In this video, we are going to discuss digital time measurement. So the content. The first point is measurement of time interval between two events. Second point, error in time interval measurement. Third point, Vernier technique for small time interval measurement. And last point, measurement of time interval with constraint. So first point is measurement of time interval between two events. So the basic block diagrams is given here. So this block diagram consists of signal input, basically it is electrical signal, then signal to time converter, then two monostable multivibrators are used, M1 and M2, and it is used. Then clock generator with the frequency Fc is given here. Then counter circuit, latch, decoder, driver circuit and display. So these are the main blocks of the digital circuit. So basically, where is the application of this circuit and why it is important? We know that the most of the signal in nature are analog. So we require to convert into digital form. Then question is why it is necessary to convert any analog signal into digital? Because the processing is done by using a digital computers, and we know that for digital computer the language is digital, that is a binary coding, that is in the form of 0 and 1. So for processing purpose we require to convert all the analog signals into digital form, because the language is in a digital computer is a binary language. Now where is the application of this circuit? Means application of time measurement. The first application is measurement of time interval between two events. Then time period measurement of any periodic signals. Then time constant of a passive circuit. We know that, let's say RL circuit, RC circuit. So these are the passive circuits. So charging and discharging time of RL circuit, RC circuit could be measured by using this circuit. Then phase difference between the voltage and current waveform could be measured by using this circuit. So these are the various applications. Then the working principle, how it work. So first is input signal. So this signal is electrical signal. This electrical signal is given to signal to time converter block. So it is signal to time converter block. So what is this signal to time converter block? Basically this is SR flip flop. It is used to measure, or it is used to generate a pulse of time interval Tx. The pulse width is Tx. So if you see here at point P, that is output, you will obtain the waveform with time interval Tx. So let's say two events are occurred. So at T1 there is first event occur. So after that at T2 the second event occur. So whatever the time duration or time interval between these two events is measured by a pulse width of Tx. So at point P we will get a Tx pulse width. So this Tx pulse width is given to one input of a AND gate. Now the second input of AND gate is a clock generator. If you see here, the clock generator is given to second AND gate. Now we know that in AND gate, if the two inputs are 1 1, at that time the AND gate is activated and it gives the signal to the next circuitry. So here the counter is used. This counter counts the number of pulses. Now for the controlling purpose, two monostable multivibrators are used, M1 and M2. Then what is the function of this monostable multivibrator? So if you observe here, as soon as the pulse is over, means at T2 the pulse is over, this monostable multivibrator generates a narrow width pulse. So at point Q there is generation of a narrow pulse. If you see here at Q, the narrow pulse is generated with the time between time T2 to T3. Now this is given to the latch circuit. So latch is enabled. So the counter stop the counting of the pulses because of the latch is enabled. So whatever the data which is transferred from the counter to the next decoder circuit, that will stop. Now to reset the counter we require one more monostable multivibrator. So this is M2, that is the second monostable multivibrator. So this M2 also generates a narrow pulse at time between time T3 to T4. As soon as the M1 will generate a narrow pulse, latch will enable and the number of pulses which passing from the counter to decoder will stop. Now it is time to reset the counter. So that's why we require second monostable multivibrator M2 that generate one narrow pulse. So at point R you can see here a small pulse is generated, so counter will stop. After that the decoder and driver circuit is used to convert whatever the binary data in the form of decimal number, and that decimal number is displayed by using this display circuit. So this is the basic working principle of digital measurement of signal or a time interval measurement. Now the second point is measurement of time interval between two events, means how this TX waveform is generated. As I already told, let's say there are two events. TA is the first event. So here is first event TA, and after some time the second event is a TB. So whatever the time duration between TA and TB is a TX, and that we want to find out by using the flip-flop circuit. So if you see the flip-flop circuit, it consists of two inputs S and R, and Q is the output. So S is nothing but set, R is nothing but reset, and Q as the output circuit. So at the starting, when first event occur, that is TA occur, so S is activated, that is flip-flop is a set. So at TA there is generation of pulse. After some time, means at the time interval Tx, the second pulse is occur, that is TB occur. So at R, means second input of the flip-flop is R, that is reset. So as soon as the TB event occur, reset circuit activate and the flip-flop again reset. It means that the output is 0. So when the TA, so between the time interval Ta and Tb, will get a width of Tx. So this is the basic idea of measurement of any time interval between two events by using SR flip-flop circuit. Then error in time interval measurement. So how to measure the error in time interval measurement? The basic formula for measurement of time interval is Tx equal to A into Tc plus B. Then what is A? A is called as, sorry, I did a mistake here. Basically A is nothing but integer, so this is integer, and B by Tc is nothing but proper fraction. It's not function, it is proper fraction. So A is integer and B by Tc is proper fraction. So this is the basic formula for measurement of a time interval. Tx is equal to A into Tc plus B. Now this is the waveform, and you will get a basic idea how to measure the error at the different events. So here in this circuit, two conditions are considered. We know that the AND gate is activated when the two inputs are given. The first input is a Tx, that is time interval of two events, and second input is clock frequency. So if you see here, the clock frequency is given with the duty cycle 50%. What is meant by duty cycle? T on period plus T off period divided by total time. Or in terms of percentage, it is multiplied by 100. So this is the clock frequency which is given to the one input of AND gate. Now let's say first case. Let's say the event is occur between A and B point. So if you observe here, the event is occur between A and B point, and so between A and B there is TA, and it is end at TB. Now, so we know that the Tx is measured as A into Tc plus B. Now during this time interval, the number of pulses is counted by the counter is A plus 1. Now what is A plus 1? Let's say this pulse, this pulse, this. There are three pulses. Plus the event is occurred between A and B. So your counter will also count this pulse. So that's why it is A plus A plus 1 pulses. Now how to find out the error? We know that the actual time interval is Tx is nothing but A plus Tc plus B. But the counter counts the number of pulses, that is 4. So obviously there is some error occur. So how to find out that error? So for this case, let's say epsilon is called as error. So epsilon is error. We know that the actual time interval is A into Tc plus B, and whatever the time interval count by the counter is A plus 1, that is number of pulses, into Tc. What is Tc? Tc is a time period of a clock signal. Whatever the signal generated by the clock generator, and the time period of that clock generator is nothing but Tc. So whatever the difference, you will get Tc minus B. At what condition? When the TA is occur between AB, means between A and B point. Now the second condition. In second condition, let's say that event occur between B and C point. So here is event occur, and the second event occur at point B. Now in this case, the number of pulses count by the counter is 1, 2, 3. So here in this case, let's say A as a 3. So number of pulses counted are 3. But in actual case, the Tx is more than 3, means whatever the time duration, this time duration is more than the actual pulses which are counted by the counter. So obviously some error is produced. So in that case, how to find out the error? We know that to find out the error, we require to take the difference between the number of pulses into time period Tc minus the actual time interval Tx. That is A into Tc minus Tx. So if you see here in the second case, A into Tc minus Tx. Tx is nothing but A into Tc plus B. So whatever the error is B. It could be positive or negative. So when the event occur between the BC point, at that time we will obtain some error which is represented by the B value. B is nothing but a proper fraction. B by Tc is nothing but the proper fraction. So if you see this, Tc minus B is occur. Tc by minus B is nothing but the error which is obtained when the value of B is less than equal to Tc by 2. So Tc is the time period of any clock signal, and so Tc by 2 should be less than or equal to B. So at that time we will get a Tc minus B as a error. So I'll take one example so that you will get a clear idea how to find out the error of any signal for the measurement of time interval between two events. So let's take this the example. Then what is given? Determine the maximum percentage error in measuring a time interval of 2.2 microsecond with the clock frequency of 1 megahertz. What would be the error if the leading edge of the clock pulses is synchronized with the initiating events? Now in this case, we have to find out the error, how much is the error generated. Now the time interval is given, that is 2.2 microsecond, that is Tx is given. So the value of Tx is 2.2 microsecond with the clock frequency 1 megahertz. So we know that clock frequency is represented by Fc, that is 1 megahertz. So in the form of time Tc, it is 1 by Fc, that is 1 microsecond. Now to find out the value of A, that is integer part, and to find out the value of the fraction part, that is B, proper fraction, that is B by Tc. So we'll just divide this 2.2 divided by 1. So we'll get the integer part as a 2 and fraction part as a 0.2. So we'll get A as 2 and B as 0.2 times Tc. We know that Tc is nothing but 1 megahertz. Sorry, Tc is nothing but 1 microsecond. So the value of Tc is 0.2 microsecond. And if you see this, it is less than Tc by 2. So Tc is nothing but 1 microsecond divided by 2. So it will be 0.5 microsecond, and our value of B is 0.2. So if we know the value of B is less than Tc by 2, so at that case we will obtain this formula to find out the error. So error is nothing but Tc minus B at what condition? When B is less than equal to Tc by 2. So same condition is obtained in the given problem. So error is nothing but Tc minus B. Now we know that Tc is 1 microsecond and B is 0.2. So we will obtain 0.8. So 0.8 divided by total time interval Tx. So 0.8 divided by 2.2 into 100%. So we'll obtain the percentage error as 36.3%. So the condition at which the value of b less than equal to Tc by 2, the error is Tc minus 2, sorry, Tc minus b. So in this case Tc is 1 microsecond, the value of b is 0.2 microsecond. So Tc minus b is 0.8 microsecond. So 0.8 divided by total time interval, that is 2.2 microsecond. So we will obtain in percentage it is 36.3% of error. So this one is the last point of this video. In next video we are going to start the Vernier scale to find out the time interval. That is next part. Here we will stop here. Thank you.